Hey guys, let's solve another geometrical problem in this video. I'll just read the problem. The figure below shows the intersection between an equilateral triangle ABC, which is ABC, and a right angle isosceles triangle XYZ. XYZ. That's a right angle and isosceles triangle. It also says that if ZX is parallel to BC, ZX is parallel to BC, find the value of the angle N. So find the value of the angle N. So that's what we are going to find. Let's solve one by one. First it says that the triangle ABC is a equilateral triangle. So in an equilateral triangle, what is the condition? All the angles, right? All the angles are equal. Equal. What it means is that all these all these angles are equal, right? But also the rule is that in any triangle, all the three angles together, if you sum them up, right? If you sum up all the three angles, it will be 180, right? So in that case, if these three are equal, then what will the value for each angle in that case? What should we do? Yes, very good. We should divide 180 by 3. So in that case, each angle, or angle A, comma angle B, comma angle C equals to 180 divided by 3, which is equals to 60, right? So this one is how much? 60, and this one is 60 as well, and this one is 60, right? We cannot write it inside because the space is very little. That's why I have written it outside. So it doesn't matter as long as you know that this measures to 60. Okay, so now the next one, it says that this triangle, right, XYZ, this one is an isosceles triangle, right? And this is a right angle. That is also another clue that is given in the problem, right? So which means this one is 90, this one is 90 degree, right? For an isosceles triangle, right, let me write, in an isosceles triangle, the two opposite angles are equal. What it means is that this is the vertex of the isosceles triangle, and then this opposite angle, see, this is the vertex angle, and the opposite angles are these two. These two are equal, right? Equal. What it means is that we know that this one is 90 degree already. So if these two are equal, according to this condition, that all the three angles added together will always be 180 for a triangle, right? So we know one is 90 already. So let's find out what is angle Z and angle Y, because they are equal, right? So in an isosceles triangle, right, two angles are equal, or two opposite angles are equal, right? Opposite to the vertex. Okay, so with that condition, see, angle Z comma angle Y equals to, how much will it be? See, all the three are 180. We know that this one is 90, so this is taken already. So whatever is remaining needs to be split between these two equally, right? Got it, right? So what it means is that we need to first subtract whatever we know, that is 90, and then we divide by 2, right? We divide by 2. Then what will be that one? 180 minus 90 is 90, divided by 2 is equals to 45. So this one is 45 and this one is 45 as well, right? So for following me, right? Okay, cool. So we have found this triangle, the value for this one, and also we have found the value for these three angles, right? We have found it. Now there is another condition, that is, clue is given in the problem that zx is parallel to what? BC, this one, right? Parallel to BC. That is given for a reason. You know why? You see here, in any triangle, you draw a parallel line to any side. Yeah, you take any side. If you draw a parallel line, only the length of the side will change, but the angle will always be same. What it means is that, see, this is a line, this is one side of this triangle, right? You just cut it through here by drawing another parallel line. See, all the angles will still be 60. Another line, all the angles will be 60. Just that the length of the sides will be shrinking, that's all. But the angle will always be same. Yeah? Okay. So with that condition, you are just drawing a line parallel to this one, parallel to this one. If you keep drawing one, at one stage you will reach here as well, right? So because this line is parallel to this one, this angle also is 60. These two angles are also 60. It is like as if you are just pushing this line above, that's all, right? You are just keep pushing it and then bringing it here, and then the angles will never change, right? The value for the angles will never change, only the length would change. Yeah, so that makes 60 degree all the three angles, even for this small triangle as well. Because we are going to find the value for n, let's give a name for this point. Yeah, let's give a name M. Yeah, always a good idea to give names at all the points that you are going to use. Yeah, okay, so here this is M, right? Now let's, with this condition, right, that zx is parallel to BC. With that condition, right, with that condition, AM, and then maybe we will give N, right, in triangle ANM. Yeah, okay, triangle AMN equals to 60 degree. See, with this condition, AMN, the M is what? The middle point of the triangle, right? This one is 60 degree. This point we have given some name because we just used it. So in this triangle, with this condition, with this clue, angle AMN is equals to 60 degree. So this one is 60 degree, right? You see here now, according to Euclidean theorem, right, any line that is, any two lines that are intersecting will form equal opposite angles, right? What it means is that, you see here, AB, right? This one is one line, and then ZX, that is another line, right? These two lines are intersecting at point M, right? At point M, and one side of the intersection, it forms 60 degree, right? That is why the opposite side also, it will form always two equal opposite angles. When two lines intersect, it will always form two equal opposite angles, right? So this is 60, so this one is also how much? 60, right? Let me, maybe I'll just put it here. It is 60 as well, because there is less space. I'm just writing it here. So this is 60, right? The angle M is 60. Now you see here, for this triangle, we know that one is, we will have to write, yeah, did we write? Yeah, we wrote this one 60, but we haven't wrote why we marked this as 60 as well. See, the line AB is intersecting on line ZX. So line AB is intersecting at line ZX, right? Line ZX. Yeah, so that will form this triangle, right? This angle is 60, so this one is also 60, but because we haven't given any address here, so let's maybe give some address here. I mean, what we will give, P is not there, right? So let's give P. Yeah, P. So that will form ZMP as 60 as well, right? That will form angle ZMP equals to 60 degree. So we have just marked this angle as 60, which is what we have just explained here. Yeah, okay. See, now from this triangle, right, from triangle ZMP, right, from ZMP, what we are going to find is, right, what we are going to find, angle N is equals to, we know that all the three triangles together is 180, right? 180. What should we do in that case? 180 minus, we just subtract the other two angles, right? Other two angles. One is 45, another one is 60. So minus 45 minus 60, right? We subtract the other two angles. So now how much will it be? See, 45 plus 60 is 105, right? Let's do that way. Let's 180, 105, right? So if you subtract, 10 minus 5 is 5, here 7, and then 0, right? 75, which is equals to 75 degree. So answer, angle N is equals to 75 degree, right? You know, if you just pay closer attention and if you remember a couple of rules, then it will be very easy to solve. Yeah, thanks for watching.